In this video, we're going to talk about the Apex pre-calculus exercises from 3.3, and the topic is going to be partial fraction decomposition. First question, can the fraction x plus 2 divided by x squared plus 2 be simplified? No, it cannot, because there's no common factor between them. X squared plus 2 is an irreducible quadratic that has only complex solutions and can't be factored over the real numbers. In the fraction 2 over x plus 3 quantity squared times x plus 2, are there any repeated factors? Yes, x plus 3 is a repeated factor, and it has a multiplicity of 2. What is meant by an irreducible quadratic? An irreducible quadratic is going to be something that can't be factored into, can't be factored across the rationals to give us a linear factors without introducing square roots into it. You can do that sometimes, but you're not going to want to do that when you don't have to. You're going to leave that quadratic. You're definitely going to have an irreducible quadratic such as x squared plus 2 when it only factors over the complex numbers. So a good example of an irreducible quadratic is right there, x squared plus 2. So we're going to leave that alone when we see something like that. Simplify the given expression in exercises 5 through 9. So this is just going to be reminding you how to make a common denominator. Let's go over this though. We have 18, which factors into 2 times 9, which is 2 times 3 squared. 12 is 2 times 6, which is 2 times 3, which is 2 squared times 3. That means that my least common denominator has to be made up of 2s and 3s. I'm be greedy and take the highest exponent off of each base that I see. So that means 4 times 9 is 36 is my LCD. To get 36 in my denominator for 5 over 18, I'm going to have to multiply by 2 over 2. To get 36 in my denominator for 5 over 12, I'm going to have to multiply by 3 over 3. This is 10 minus 15 in my numerator. 36 in my denominator is negative 5 over 36. I have x over b minus b over x. I don't see numbers that I can make factor trees with like I did previously, so I'm just going to have to get a common denominator from all the factors multiplied together. So my denominator is going to be bx, and this is going to be x squared minus b squared. I'll factor that a little bit more into x plus b times x minus b over bx, like that. My next one says x over y squared minus x over x plus y. X plus y is its own factor altogether. It's a binomial factor. So I'm going to have to multiply here by x plus y over x plus y. And here I'm going to have to multiply by y squared over y squared. That gives me a common denominator of y squared times x plus y. I have x squared plus xy minus xy squared. And that's it. I'm not going to be able to factor that. And I have a common factor of x, so I will factor that a little bit more. This is x plus y minus y squared over y squared x plus y. There we go. I've proven that there's no common factors that can cancel. Number 8 is a complex fraction, 1 over x minus x plus 2 over x squared is my big numerator. And my big denominator is 4 over x squared minus x squared plus 1 over x to the third. So my LCD for everything is going to be x to the third. So I'm going to multiply by x to the third over x to the third. That gives me x squared minus x times x plus 2 over x times 4 minus x squared plus 1. It's going to give me x squared minus 2x over 4x minus x squared minus 1. X squareds will make a 0. This is going to be negative 2x. And then I'm going to factor out this negative x squared minus 4x plus 1. Cancel those out. And that's going to leave me with 2x over x squared minus 4x plus 1. I cannot factor this quadratic because there are no factors of 1 that add up to be negative 4. That's an irreducible quadratic. So I'm going to leave it. Now I have 1 over x minus b minus 1 over x over b. This is looking a whole lot like a difference quotient here, but not quite. It's very close to a difference quotient. So our LCD here is going to be x b, x minus b, x b, x minus b. So when I do that, x minus b cancels, and the first one leaves me with xb. X cancels and leaves me with b times x minus b over x b squared x minus b. It's going to give me xb minus xb plus b squared over xb squared times x minus b, b squared over xb squared x minus b, and that's going to leave me with 1 over x times x minus b. This is assuming that b is not equal to 0 here when I canceled that out, because I can't cancel out 0 over 0. All right, now we're going to do partial fraction decomposition. Starting with number 10, we have x minus 8 over x plus 2 quantity cubed. So this is a linear factor. So we're going to go 1 degree less for our numerators and say that this is a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed. I've got to get every power of it represented is equal to x minus 8 over x plus 2 cubed. So we're going to multiply everything by x plus 2 cubed, and that's going to give me a times x plus 2 squared plus b times x plus 2 plus c is going to be x minus 8. I'm going to have a times x squared plus 4x plus 4 plus bx plus 2b plus c is equal to x minus 8. Ax squared plus 4ax plus 4a plus bx plus 2b plus c is equal to x minus 8. So I'm going to look at my x squared terms. A x squared is equal to 0 x squared on the right, so a has to be equal to 0. So everything with an a in it is a 0, leaving me with this all is 0. Bx plus 2b plus c going to be equal to x minus 8. So now my only part that has an x is there's one x over here, so b has to be 1. If b is 1, then I have x plus 2 plus c is equal to x minus 8. C is going to be equal to negative 10. So those are my coefficient or my numerators here, that I should have 1 over x plus 2 squared plus, minus 10 over x plus 2 to the third is going to break down and give me x minus 8 over x plus 2 to the third. Oh, it says do not solve. Oops. Oh, well. We won't solve next one. All right, 4 over s minus 1 squared, 2s minus 5, and s plus 3. So we're going to need an a over s minus 1 plus a b over s minus 1 squared plus c over 2s minus 5 plus d over s plus 3. It's number 11. And we would use the system of equations that we're going to generate from that to solve for a, b, c, and d. But they don't want us to solve. In this one, we have 5t squared plus 11t minus 9 over t plus 1 to the third, t squared plus 1 squared. This is an irreducible quadratic, so we're going to have to deal with that in this one. We have t plus 1 to the third, so that's a over t plus 1 plus b over t plus 1 squared plus c over t plus 1 to the third plus, now we have degree 2. So our numerator is going to have to be degree 1, which is going to be an mx plus b form. So I've got dx plus e over t squared plus 1. Oops, I need to make my variables match here. dt plus e over t squared plus 1 plus, and I'm going to have a t squared plus 1 squared. So I need a f t plus g. Yeah, so there we go. That one would be really messy, and I'm glad they're not making us solve for it. 13, 6x over 4, x minus 4, x squared plus x plus 5. This is an irreducible quadratic. So we have a over x minus 4 plus bx plus c over x squared plus x plus 5. 14, 3x minus 7 over x to the fourth minus 1. A 3x minus 7 over x squared minus 1 times x squared plus 1 is 3x minus 7 over x plus 1, x minus 1, x squared plus 1. X squared plus 1 is an irreducible quadratic. So that's a over x plus 1 plus b over x minus 1 plus cx plus d over x squared plus 1. 15, 2s over s to the third plus 1, s to the third plus 1 factors into s plus 1 times s squared minus s plus 1. That's an irreducible quadratic. So this is going to be a over s plus 1 plus bs plus c over s squared minus s plus 1. 16, 11 over t squared minus 6t plus 5 breaks down into t minus 1, t minus 5. So that's going to be a over t minus 1 plus b over t minus 5. Now they want us to give the full decomposition of the fraction like I was starting to do in the first problem. So x plus 5 over x squared plus x minus 2 be x plus 5 over x plus 2 times x minus 1. That makes this a over x plus 2 plus b over x minus 1 is equal to x plus 5 over x plus 2 times x minus 1. And multiply by our LCD, a times x minus 1 plus b times x plus 2 is going to give us x plus 5. So because I have distinct linear factors, I'm going to let x be equal to 1, my first one, so I get a 0 there. That's going to give me 3b is equal to 6 and b is equal to 2. Now I'm going to let x be equal to -2, and -3a is equal to 3, and a is equal to -1. So that's a valid way to do this, to choose x values, to solve for a and b that will give you zeros, especially when you have all distinct linear factors. Not so helpful when you have irreducible quadratics, not so helpful when you have repeated roots. So this means that x plus 5 over x squared plus x minus 2 is equal to -1 over x plus 2 plus 2 over x minus 1. One over x squared minus a squared is equal to 1 over x plus a times x minus a. That gives me a over x plus a plus b over x minus a is equal to 1 over x plus a times x minus a. This is a times x minus little a plus b times x plus little a is equal to 1. So when x equals a, then we have b times 2a is equal to 1. b is equal to 1 over 2a. When x equals -a, we have -2 little a times a is equal to 1, and capital A is -1 over 2a. So we break that down into 1 over x squared minus a squared is equal to -1 over 2a over x plus a plus 1 over 2a for x minus a, like that. You can simplify that if you want to get the 2a's out of there by saying something like that. So there we go. That was number 18. Number 19, 2s squared minus s plus 4 over s cubed plus 4s. 2s squared minus s plus 4 over s times s squared plus 4. That's an irreducible quadratic. So we're looking at a over s plus bs plus c over s squared plus 4 is equal to 2s squared minus s plus 4 over s times s squared plus 4. Now we're going to multiply by the LCD. I am not going to try to let s be equal to something here. I'm going to use my other technique that I showed you before. So for my s squared terms, I have a plus b. S squared is equal to 2s squared. So A plus B has to be equal to 2. I have CS as my only S term is equal to negative S. So C has to be negative 1. And I have 4A as my only constant term is equal to 4. So A is equal to 1. So if A is equal to 1, 1 plus B is equal to 2, and B is equal to 1. Therefore, I should be able to come back here and say that my simplified version is 1 over S plus S minus 1 over S squared plus 4. That should be the same thing as 2S squared minus S plus 4 over S cubed plus 4S. It won't become obvious to you why you want to do this until you get to integration and calculus. But we want to take something like this that we cannot easily integrate, and we want to break it up into two parts like this, which are both very easy for us to integrate. So with a little bit of effort, in fact, we would split this up even more, and we would call this, and we would deal with this piece separate from that piece. But go. Y minus 1 over y squared plus 3y plus 2 is going to be y plus 1, y plus 2, y minus 1. We're going to break this up. A over y plus 1 plus b over y plus 2 is equal to y minus 1 over y plus 1 times y minus 2. A times y plus 2 plus b times y plus 1 is equal to y minus 1. I do have distinct linear factors here, so I'm going to let y equal negative 2. And that's negative b is equal to negative 3, so b equals 3. Then I'm going to let y be equal to negative 1. And that's a equals negative 2. So I have negative 2 over y plus 1 minus 1 over y plus 2 is equal to y minus 1 over y squared plus 3y plus 2. For 21, 4x over x to the third minus x squared minus x plus 1. Going to try and factor by grouping here first if we can. X minus 1 minus x minus 1, 4x over x minus 1 times x squared minus 1, 4x over x plus 1, x minus 1 quantity squared. So that's going to give me a over x plus 1 plus b over x minus 1 plus c over x minus 1 quantity squared is equal to 4x over x plus 1 times x minus 1 squared. A times x minus 1 squared plus b times x plus 1 times x minus 1 plus c times x plus 1 is equal to 4x. I'm going to try to use x equals 1 and x equals negative 1, but it's not going to give me a complete solution here. It is going to give me a system of equations that I'm going to be able to work with. So when x equals 1, then I have 2c is equal to 4, c is equal to 2. When x equals negative 1, then that is 4a is equal to negative 4, a is equal to negative 1. So I can make some, now I'm going to pick a third a third x value that's just kind of random, but I'm going to pick one that's nice and easy for me to work with, like x equals 0. And this is going to give me a minus b plus c equals 0. Well, I know what a and c are. A is -1, c is 2, and so that's 1 minus b is equal to 0, so b is equal to 1 if I add b to both sides. So we should be able to rewrite this now as a is -1, b is 1, c is 2, and that's going to be equal to my original of 4x over x cubed minus x squared minus x plus 1. That's a 4. Okay, so that was our partial fraction decomposition for number 21. They have not shown us one where we have to do long division first. That's always the first thing to check, is that if the degree of the top is greater than or equal to the degree of the bottom, we're going to have to do long division of polynomials before we start our partial fraction decomposition. So I might go pull some extra problems from a worksheet in just a second to show you, since this is such an important skill. Going to factor the denominator, x times 2x squared plus 3x minus 2 squared plus 2x minus 1, x squared plus 2x minus 1 over, and then I think that this is going to factor some more, 2 and 2 and -1 and 1, like that. This is 4 minus 1 is 3, -1 times 2 is -2. This is a over x plus b over 2x minus 1 plus c over x plus 2 is equal to x squared plus 2x minus 1 over x times 2x minus 1, x plus 2. It's going to give us a times 2x minus 1 times x plus 2 plus bx times x plus 2 plus cx times 2x minus 1 is equal to x squared plus 2x minus 1. I use my technique where I'm going to let x equal something. So the 0 of this first factor here is x is equal to 1/2. And when I do that, b times 1/2 times 5/2 is equal to 1/4 plus 1 minus 1. So b times 5/4 is equal to 1/4. And multiply by the reciprocal on both sides, 4/5. 4/5. B is equal to 1/5. Now I'm going to let x be equal to -2. And when I do that, I have c times -2 times -5. -4 minus 1 is -5 is equal to 4 minus 4 minus 1. So 10c is equal to -1. C is -1/10. Then I'm going to let x equal 0. When I do that, I have a times -1 times 2 is equal to -1. -2a is equal to -1. A is equal to 1/2. So I have, scroll back up here a little bit. So I have 1/2 over x plus 1/5 over 2x minus 1. Don't be scared of these fractional numerators. Minus 1/10 over x plus 2 is equal to x squared plus 2x minus 1 over plus 2, 3, -2. Two, 3, -2, and this was cubed squared and x, right? Yes. Okay. Again, nothing wrong with leaving those fractions in the numerator. They're going to be helpful when you get to calculus 2 because they're just going to be constants that you pull out front. So don't worry about them. That was number 22. Give me just a second and I'm going to find some additional problems for us to work that require long division. All right, these problems here are from a website called CUDA Software. It's another open educational resource. So I'm going to do number 3 as an example here of one of the ones where the degree at the top and the degree at the bottom were the same to start off with. So that's x squared minus 6x plus 5 is my denominator. My numerator is -2x squared plus 4x plus 14. X squared is going to go into -2x squared -2 times. -2x squared plus 12x minus 10. I'm going to change my signs now and do that in red. Addition changes to subtraction. Subtraction changes to addition. So go back to black here. This makes a 0. 4 minus 12 is a -8. 14 plus 10 is 24. So we're looking at this simplifies to -2 plus a -8x plus 24 over x squared minus 6x plus 5. Now this part that's a proper fraction now is what I have to do partial fraction decomposition on. I leave this -2 just sitting out here. And this is x minus 1, x minus 5. This is -8x plus 24. So this is -2 plus a over x minus 1 plus b over x minus 5 is going to, and I'm really only, again, worried about, don't forget about this -2. I'm only worried about this -8x plus 24 over x minus 1 times x minus 5 at the moment. We're going to come back and put that -2 in the answer. Don't forget this. It's part of the answer. But we're just doing some scratch work on the side right now. This is a times x minus 5 plus b times x minus 1 is equal to -8x plus 24. So this is going to be let x equal to 5. When x equals 5, we have 4b is equal to -40 plus 24. 4b is equal to -16 b is equal to -4. When x is equal to 1, then we have -4a is equal to -8 plus 24 is 16, and a is equal to -4 as well. So our final answer is going to be -2 minus 4 over x minus 1 minus 4 over x minus 5. Because these are -4s, we're just going to put them as subtraction there. Let's do another example like that, where the degree of the top was greater than or equal to the degree of the bottom. And do number 4. 2x squared minus 9x minus 10 over x squared minus 5x. X squared minus 5x is on the outside. 2x squared minus 9x minus 10. And we don't need to have every factor or every power of x represented on the outside. We do on the inside, so we're good. 2x squared minus 10x, change my signs and add. X minus 10. X minus 10 is my remainder over x squared minus 5x. 2 plus x minus 10 over x times x minus 5. So I'm going to take this part right here to do partial fraction decomposition with it and say that that's a over x plus b over x minus 5 is going to give me a times x minus 5 plus bx needs to give me x minus 10. So I'm going to let x equal 5. When that happens, 5b is equal to -5 and b is -1. And then I'm going to let x equal 0. And when that happens, -5a is equal to -10 and a is equal to 2. This is 2 plus 2 over x minus 1 over x minus 5. So you're going to have a whole part sometimes, and they're doing it in both of these examples where it just comes out to be a number, but it could come out to have some letters in it too. If I had a x cubed divided by an x squared, I could have a linear part here. Not linear, but I could have a part that has an exponent of 1 and an exponent of 0, as well as what I'm seeing here. So, all right, absolutely make sure that there's no other ones like what I'm thinking about. Everything else looks like a proper fraction to me. So we're done. Let's just go ahead and show. That's what we got. And this is what we got before. That was a -2 out front, and it was -4 and -4. All right. That is everything for partial fraction decomposition right now. Again, that will come up in chapter 8 of our Larson calculus textbook that we use at Reynolds. I'm not exactly sure where it's going to come up in the Apex calculus book, but I will do some Apex calculus videos, and we will be talking about that when we get to the calculus 2 material with integrals that come out with answers that are logs. So be prepared for that. Have a good day. Bye.